Good morning everyone, I'm Armstrong Galvez.
I'm Denise Robayo and Mendel Joyce Alvarez.
I'm Crisanio Malion.
And we're going to be doing experiment 5, which is the reduction of sample size by quartering method and determination of specific gravity, water absorption, moisture content, and densities of fine aggregates.
For the tools and equipment, we have fine aggregates, shovel, tin can, aluminum containers, sieve number 4, mixing pan, weighing scale, drying oven, masking tape, pen and tape measure. The research objectives are to determine the specific gravity, water absorption, moisture content, and densities of fine aggregate sample, which testing sizes were taken by the use of quartering method, and to be able to discuss the results derived from data collected in the experiment. For the procedure, we measure first the containers. Number 1, we weigh the empty containers using a scale and note their mass. Number 2, we measure the height, width, and length of the containers. And then, we get the sample size reduction by quartering method. Number 1, we pour the fine aggregate sample into the mixing pan. Number 2, we stir the sample with a shovel, rotating it at least 3 times to form a cone shape. Number 3, we flatten the pile by pressing down with a shovel. Number 4, we divide the pile into 4 equal parts. And then number 5, we remove diagonally opposite quarters. And for the last step is that we repeat the steps 3 to 5 until the desired sample size is attained. After quartering method, number 1, we use sieve number 4 to sieve the sample, then distribute the sieve sample into 6 designated containers. Number 2, we select 3 samples from the 6, saturate them with water ensuring absorption, then remove excess water. Number 3, we weigh and document the final mass of the 3 dry and 3 wet samples. Number 4, we label each container with its sample number, category, group name, and section. Number 5, we place both wet and dry samples in a drying oven for a minimum of 24 hours. Number 6, upon removal from the oven, promptly record the weight of the samples as weight of oven dry specimen and air. Number 7, we allow the samples to cool at a room temperature for 1 to 3 hours. After that, we determine specific gravity and water absorption by achieving SSD condition. Number 1, following the cooling period, we rinse the wet samples and immerse them in a water at room temperature for 15 to 19 hours. Number 2, after immersion, we carefully remove the samples from the water, preventing any loss of the fines. Number 3, we spread out the samples in a flat, non-absorbent surface, occasionally stirring to aid uniform drying. Number 4, subsequently, we place the samples in the drying oven for a minimum of 24 hours. Number 5, post-oven drying, we record the weight of the sand as SSD or saturated surface dry mass. After the steps for achieving SSD condition, we determine the specific gravity and water absorption container calibration. Number 1, we fill the container with water up to the calibration line, noting this as weight of container filled with water. Number 2, we add SSD sand and water to fill 90% of the container. Number 3, we invert, roll, and manually agitate the container to eliminate trapped air. And then for the last step, number 4, we record the weight as weight of container with sample and water. For the result analysis and discussion, the mean bulk specific gravity SSD indicating the weight of aggregate per unit volume in air with voids filled after submersion for 15 hours is 2.7918 grams. Bulk specific gravity SG is 2.7005 grams, falling within the specified range for fine aggregates of 2.6 grams to 2.9 grams as per ASHTO T84. Understanding the specific gravity is vital for determining solid aggregates volume and void percentage. Sample 1 exceeds the water absorption standard for fine aggregates with a value of 1.59%, suggesting further water extraction to achieve levels below 2% for the sample 2 and sample 3. The normal density is 1.3393 grams per cubic centimeters and the bulk density is 1.3787 grams per cubic centimeters, both falling within the acceptable range set by AASHTO T84 for the fine aggregates of 1.20 grams per cubic centimeters to 1.75 grams per cubic centimeters. In conclusion, the experiment was conducted with the primary objective of assessing various properties of fine aggregates, including specific gravity, water absorption, moisture content, and densities. The utilization of quartering method facilitated the acquisition of representative testing sizes essential for accurate analysis. The results obtained emphasize the critical role of employing meticulous testing methodologies and thorough data analysis in the evaluation of fine aggregates, particularly in the context of construction applications where the quality and performance of materials are paramount. By scrutinizing these properties with precision, engineers and construction professionals can make informed decisions regarding the suitability of fine aggregates for specific project requirements, ensuring the integrity and durability of structures in the built environment.